I'm sure you've heard about physics before. Some people say it's hard. Other people say you have to study it if you want to be an engineer or a doctor. But physics is actually way simpler than what you might think. The word physics comes from the Greek words physis, which means nature, and physik, which means knowledge of nature. So, it's really about studying nature and how it works. So, what kind of things are studied in physics? You'll study energy, force, light, and movement. You'll look at the way matter moves through space and time, and how things like energy and force affects that movement. What we're trying to discover in physics is how exactly the universe behaves. So you'll be learning about the fundamental laws of the universe. Like, why don't we float up into the sky? Or why our hands look different when we put them underwater. Physics is actually one of the oldest academic disciplines. Nearly every civilization had some form of physics. It's the way that we understand the world in a scientific way. But what relevance does it have to other subjects? Both chemistry and biology rely on the laws of physics in order to perform calculations. But physics also impacts our daily lives. Cell phones and computers were created by following the laws of physics that study electricity. The same goes for kitchen appliances. Motor cars were invented when scientists discovered how to convert fuel into kinetic energy to get the car moving. And that's also how factory machinery was built. Even in medical care, machines like X-rays and ultrasounds were created by studying the principles of light and electricity. In fact, if you look at any human invention, you will see the influence of physics. Even creative industries like film production benefit from the study of physics. So it's actually quite important. And not just for old men. So what do we know about physics? We know that it means the study of nature. More importantly, physics is about examining how matter moves through space and time, and how it is affected by things like energy and force. And by studying this, we can begin to understand some of the fundamental laws of the universe. Physics covers a huge range of topics, including light, electricity, movement, energy, and force. And the study of physics has led to all kinds of inventions that we use in our everyday lives. See? Physics is awesome.
Welcome to this lesson, PHY191, which is General Physics Practical, and this is our lesson one, our first lesson, which is graph, the introduction to graph. I'm going to put you through some basic knowledge about graph and how to plot graph, the importance of graph generally. But first of all, let us explain what graph is and what they are used for. First of all, as a physics student, you are going to engage in some observation of some physical phenomena, which will now lead you to measuring some important quantities such as length, mass, time, electric current, temperature. Now these are called fundamental quantities. Well, they are fundamental quantities because they do not depend on any other quantities for their value. Simple. Meaning they are independent, or they don't depend on other quantities. Other examples of fundamental quantities are intensity of light, we have amount of substance, but the most common and important is length, mass, time, and rarely temperature. Now, fundamental quantities are very, very important also because from fundamental quantities, that is where we get derived quantities. Derived quantities from the name, derived, they are derived. They depend on fundamental quantities for their value. Example of derived quantities are force, pressure, area, volume, and we have a whole host of others. Now, in graph, now the measurement of these quantities is very, very important because we use this measurement and the relationship to get constants. We measure this variable and plot a graph of two different variables, we get a constant, right? So examples of constants are acceleration due to gravity, elastic constant or stiffness. We also have specific heat capacity, we have heat capacity, we have resistance of a material. These are all constants, and constants are gotten from the relationship between one or two quantities or variables. Now, how do we get this constant? We get this constant using graph. So this is why graph is very, very important. So briefly, let me define graph. A graph is simply a data chart intended to illustrate the relationship between a set of numbers. If you notice, data chart is written in another color to tell you how important data chart is in graph, because we cannot plot a graph without getting data, and data are gotten from the observation of variables, right? Now, so it is intended to illustrate the relationship between a set of numbers. So we get numbers, data, and then arrange them, plot a graph, and check the relationship between this variable and another variable, how this one affects the other. So that brings us to variables. What are variables? Variables, from the name variables. Variable is something that varies or changes, that is not constant. So variables give us constant. So variable is a quantity that may assume any one of a set of values. So it changes. In simple terms, variables are quantities that change, right? That do not remain constant. Example, time. Time is a variable because time can change. Length is a variable because length can change, and most other variables. So we have different types of variables. Two types of variables in general. We have the dependent variables and the independent variables. Now, dependent variables are variables that depend on the independent variables. So I will explain that to you further when we get to this diagram here. Now, so if one quantity P is depending on another quantity Q for its value, so we would say that P is the dependent variable because it is depending on the other variable q, while q is the independent variable because it does not depend on variable p. It is independent while p is dependent. So let us briefly look at this diagram. So graph is drawn on the Cartesian plane. Cartesian plane is simply two number lines that intersect on an origin, and the origin is labeled O or 0. So we have the vertical axis and the horizontal axis. The vertical axis is called the y-axis, and most of the time the dependent variable is always on the vertical axis, while the independent variable is always on the x-axis. The x-axis is called the horizontal axis. So this is the horizontal or x-axis, and then this is the vertical or y-axis. And then when they are plotted, the values of the dependent is on the y-axis, the value of the independent on the x-axis, and then we now study the relationship and observe how a little change in the x-axis affects the y-axis, and then it now gives us the slope or gradient. Then from the slope or gradient we get our constant, right? So the slope gives us the constant. Now so this is okay. Let me note, you need to note that there are two types of graph general. So we have the graph from the origin. We have the straight line graph starting from the origin, and we also have the straight line graph that is not passing through the origin. So this one is passing through the origin. The other one, which is not passing through the origin, will be discussed later. But for now, let us pay attention to the straight line graph passing through the origin. This is our origin, so this is passing through the origin. And the equation of the straight line graph passing through the origin. So the general equation of a straight line graph is given as y equal to mx plus c, right? So y is called the dependent variable, m is called the slope or gradient, while x is the independent variable and c is called the intercept. The intercept. So we are not going to bother ourselves with intercept for now, because now we'll only be focusing on graph that is passing through the origin. Now, since our graph is passing through the origin, or our straight line is passing through the origin, our intercept is going to be 0. So if intercept is equal to 0, our graph reduces, so our equation reduces to y equal to mx, because c is 0. So we'll be focusing on the graph or the slope passing through the origin. So for now, let us see how we can calculate our slope, right? Our slope is very important, and we use our slope to get our constant. Our slope is our constant, all right? So how do we get our slope from the equation y equal to mx plus c? Now I'm going to put you through this. So when we put in our values and plot the graph, now from the graph, let me wipe this off so that we can Alright? So on our straight line, we get 2 points. Any 2 points on any part of the straight line will be here, it will be here. So we call the first one A, and we call the second one B. And then we find the coordinate of this B on the x-axis, we call it x2, and then trace the coordinate to the y-axis, we call it y2, and then we also do the same for A. We trace the coordinate on the x-axis, we call it x1, and then trace the coordinate on the y-axis, call it y1. So from there we have a right angle triangle. So this line is called delta y, and this line is called delta x. Delta is just a Greek letter which stands for change. Delta means change. So this is change in y, and this is change in x. So the slope of a graph or the gradient is given as the change in y, which is y2 minus y1, which is this line from here to here, which is this line. So the length of this line divided by the length of this line, which is x2 minus x1, which is equal to delta y over delta x. Okay? So this is how we get our slope. So y is equal to y2 minus y1 over x2 minus x1 close bracket x. So because m, which is our slope, is equal to delta y over delta x. So we are going to look at some examples, right? Okay, so let us look at a quick example of how to find our slope or gradient, right? But before then, let's do a little recap. First of all, we have a graph. We have the y-axis, or the dependent variable on the y-axis plotted against the independent variable on the x-axis. Now our straight line is passing through the origin. That is why the equation of this straight line, or the straight line equation, is y equal to mx. If this was not passing through the origin, we are going to have an intercept on the y-axis, but because it is passing through the intercept, because it is passing through the origin, our intercept is 0. Therefore, the equation reduces to y equal to mx. So, looking at this graph here, the equation is y equal to mx. This is our slope. Our slope is m. This is the dependent variable slope, independent variable, and our slope is calculated by getting 2 points on the straight line, and then we trace the coordinates of point A to the x-axis. We do the same on the y-axis. We also trace the coordinates of point B on the x-axis. We trace the coordinates of B on the y-axis, and then we get a right angled triangle. This is delta x, which is x2 minus x1, and then this is delta y, which is y2 minus y1. So our slope is just y2 minus y1 over x2 minus x1. Like I said earlier, delta is just a Greek letter to denote or represent change, right? So our slope y2 minus y1 over x2 minus x1, which is equal to delta y over delta x m, right? So if we, on this equation, if we replace, because this is equal to m, if we replace or substitute y2 minus y1 over x2 minus x1 for m, so we now have this. So our equation changes to this: y equal to y2 minus y1 over x2 minus x1 close bracket x, because m is equal to delta y over delta x. Okay, so this is a brief summary of how to get our slope or gradient on the graph. So let us have an example. Let's say we have straight line. Now, to get our gradient, we find 2 points, any 2 points. It could be here, 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 anywhere on the straight line. Then we could find another point, say this. We call this point A, and we call this point B. Point A and point B. And then the next thing, we trace the coordinates of point A on the x-axis. This is our x1. We trace on the y-axis. This is our y1. And then we also trace point B, x-axis. So this is y2, and we trace it to the y-axis. Sorry, this is x2, and this is y2. So we have a right angled triangle. So this is delta x, and this is delta y. Remember that delta x is equal to x2 minus x1, and then delta y is equal to y2 minus y1, and our slope, which is m, equal to y2 minus y1 over x2 minus x1, which is delta y over delta x, right? So now it's just to impute our values into this equation. So here our m for this straight line is equal to our y2 is 20 minus y1 is 5 divided by x2 is 4 minus x1 is 1. So we have 20 minus 5 is 15 divided by 4 minus 1 is 3. So our slope is equal to 15 divided by 3 is 5. Now, one thing that is very, very important is the unit, right? Is the unit. So this is our origin. Now the unit of the independent variable, which is time, is seconds, and then the unit of our dependent variable, which is displacement, is meter. So time is measured in second, the displacement is measured in meters. Now, since we know that our slope is meter over second, so our unit, the unit of our slope, is now meters per second, right? Or meters per second. So our slope, the unit of our slope is gotten from the unit of the dependent and the independent variable. So we can see how that the slope depends on the relationship between the dependent and the independent variable. Now, we can also see that if we choose not to take our 2 points here, we can take our 2 points from any other place. Let's say here, here, and here. We'll still arrive at this value. Let's say we take our point A, let's call this point C and point D. And we also choose to measure, this is our x1, y1, x2, and y2. We have a right angle triangle. If this is our delta x and delta y. We will see how that this will be equal to this. This is equal to this. Sorry. Alright, so our slope on this is going to be 15 minus 10. 15 minus 10 divided by 3 minus 2. 3 minus 2, which is equal to 5 over 1 equal to 5. So you see how that you can take your 2 points from any place, anywhere at all, and then you get the same answer, right? So I believe now we've seen how that we can measure our slope or gradient from the relationship between the dependent and the independent variable. Thank you. There are several other relationships that you can check and solve on your own. Thank you very much.